Good afternoon, class. So today we're looking at a new topic, sine, cos, and area rule. So thus far, we are told that in grade 10, we have learned how to solve right angle triangles. So everything in trigonometry for us was dealing in right angle triangles. Now we're going to delve into sections of trigonometry that deals with non-right angle triangles. Okay. Remember, life can't stay so easy. No? You must spice it up now and then. No?
Yes.
Right. So let's spice up your life quickly. So here we are told that this is a reminder that sine, cos, and tan is Sokotoa or Oliver has a head of apples. So however you want to remember it, it works for you. Okay? Whilst this is going to be sine of theta is going to be y. If you conclude this, you're going to get a right angle triangle there. This is your x and your y. So sine is y over r, cos is x over r, and tan is y over x. Okay. But we normally just use it as it is there. And note, in any triangle, opposite the capital A. Remember the capital A denotes the vertex. Opposite will be lowercase a. Opposite B will be lowercase b. Opposite C will be lowercase c. However, if we have this, we have a triangle within a triangle, and that is A, and this whole length is lowercase a. You understand? Or if you got two triangles here, and that's the B there, or this is a C here, then we would rather call this length by its full name, which is AB, and so on. Okay, so it's not always that it's going to be considered as a lowercase value there, but that is just the shorthand there. It's useful, especially when the sums get a bit bigger there. If we are told to solve a triangle, we need to calculate the length of, so also if they ask you to solve this triangle, that means you say you must calculate all the unknown angles and all the unknown sides. Okay. To solve the triangles, we need to calculate the lengths of all the sides and the size of all the angles. In order to determine any unknown of any triangle, we need to know at least 3 elements of the triangle, one of which must be a side. Write all answers correct to 2 decimal places where necessary. Right, first things first. And it's a bit smaller. Push more. How's it? The question, example 1. This example is on page. Sorry? Example on page 331. The question says solve triangle ABC. People even say solve triangle. I must calculate all the unknown angles and all the unknown sides. We are then told that angle A is 90 degrees. Then B is 25 degrees here. So what must we calculate? I must calculate C. I must calculate lowercase b, and I must calculate lowercase a. You guys understand? Alright, so let's start with the easy one. C. You're going to say angle C is equal to 180 minus 90 minus 25, which is 65. Why? Sum of triangles. People, do I need to give a reason there? Why not? Be not busy with Euclidean geometry. Unless the question says with reason, then I must state the reason. Then there's a mark allocated for reason. You guys understand?
Yes, sir.
But because it's not specified, so you don't have to work that out. Okay. And you say then it's going to be sum of triangles. Okay, that is 65. How are you going to calculate lowercase b? What do we have? B, okay. Lowercase b is what to this angle? Opposite. What do we have? Adjacent. So which trigonometric function is opposite and adjacent? Tan. So we say tan of 25 is equal to b over 5. So what do I do now? Cross multiply. So 5 tan 25 is equal to b. So b works out to be 5, 10, not 10, 25 gives us 2 comma 2. Sorry, 2 comma 3. Okay. 2 comma 3, 2 comma 3 3. As you can see, the laser given C. So this I can also fill in here now. So how are you going to calculate A? How are you going to calculate A? People, there's many ways to calculate A. How can I calculate A? Sine. Opposite and hypotenuse. Not so. Opposite and hypotenuse. Sine. How else? Cos, which is adjacent and hypotenuse. Not so. How else? Pythagoras. Yes. And God said Pythagoras 3 times in a row. What do you get? Pythagoras. Right? Why? Because that's a right angle triangle and I have 2 sides. So what do I say? A squared is equal to 2 comma 3 3 squared plus 5 squared. So this is an answer of that answer squared plus 5 squared. I'm going to give you 30 comma 44. Right, so it's going to be 30 comma 44 and the square root thereof. Okay, square root of that answer 5 comma 51. This is C. Otherwise, if you had used sine, so sine is opposite and hypotenuse, or I could have used cos. Cos is adjacent of hypotenuse. No? I'm going to rather use cos because if I had made a mistake there, you would have filtered into this answer here as well. You understand? So you're going to say cos of 25 is equal to adjacent, which is 5 over hypotenuse. So that's over 1, a cross multiply. So it's going to be a cos 25 is equal to 5 divided by cos 25 both sides. So a is going to be 5 over cos 25. So that's the calculator. 5 over cos 25. U 5 comma 5. And you have got 5 comma 5. It's about the same. Not so. Yeah, rounded if you have. But anyway. You guys understand? If you had done either or, you're going to get the full mark. Provided you don't make a mistake. Okay? Any confusion here, people? So I've calculated all the unknown sides and all the unknown angles. Okay? Example 2.
Sir,
Yes?
can you use that other method for like when you're calculating non-right angle triangles?
What method?
The second one.
This, no. You couldn't use Pythagoras either. Because the Pythagoras and this trigoration, the 3 trigorations, could only be used in right angle triangles. Okay. Anything else? Good example 2 is on page. Sorry? 3? 32. Okay. So intra-angle PQR. But now, I don't think that, let me just check. Yeah, here's a triangle. Intra-angle PQR. Let me just make this a bit smaller. Intra-angle PQR. We are told the angle Q is 90, angle P is 34 degrees, PR is 40. Calculate the length of QR. Now, do I have to calculate all the unknown sides and all the unknown angles here? No, because I didn't say solve triangle. You see the difference? It only says QR. So what do we have? We have the hypotenuse If you're going with this angle, then this is going to be your opposite. If it was this angle, this would have been your opposite. Did you see the difference, people? It depends on which angle you have. Okay? So that is your opposite. What do we have? The? So which trigonometric function uses opposite and hypotenuse? Sine. So let's go. Sine of 34 degrees is equal to opposite, which is QR over 14. Okay. So how do we solve for QR? That over 1 and then cross multiply. So QR is equal to 14 sine 34 degrees. Then your calculator says 14 sine, that's 17. 14 sine 34 degrees gives us 7,82 centimeters. That's correct? Any confusion there? Let me know if I make a mistake. Okay. The next one, example 3. The diagram as well here. Still on the same page?
Yes, sir.
Example 3. Example 3, we are told the intra-angle LMN. Angle L is 90 degrees, LN is 8 centimeters, MN is 12. Calculate angle N. Again, do I have to now calculate all the unknown angles and all the unknown sides? No. Question did not read solve the triangle. Okay? So, what do we have opposed to this angle here? In relation to the angle, sorry. We have hypotenuse. Why is that the hypotenuse? It's opposite the 90. What else do we have? The adjacent is an angle next, it's a length next to the angle. So which trigonometric function uses adjacent and hypotenuse? Cos. So you say cos angle N is equal to adjacent, which is 8 over 12. So angle N is going to be r cos of 8 over 12. Okay. So r cos of 8 over 12 gives you 48,19. 48,19. So with any confusion there, you can't get simpler than this. No, Zosie? So they smile and she said, yes. But just stay so, no? Right, so that basically brings us to the end of the examples for exercise 10.1. Is that correct?
Yes, sir.
Yeah, for homework, it's going to be exercise 10.1, all the odd numbers. Okay. You guys can start with it now. If you have a problem, you can bring it to me. Otherwise, the full lesson can be found in the description box below.